I'll start the recording now. So I think the majority of people have already joined. So why don't we get going? Okay, so can everyone see my screen?
Yep.
Yeah.
Yes.
Yes, all good.
And it is working. Good. Okay. Well, thanks very much, everyone, for joining me. This is the second of the Clean Code Nuggets. Apologies it's taken so long to get this together, but it's here now. I know it says April. We were going to give this on earlier this week, but we had to delay it. So let's get going. So in this presentation, we'll briefly recap what Clean Code is. Then we'll have a quick look at some of the concepts relating to functions. And then finally, we'll outline some guidelines to writing good functions. So please feel free to ask questions as we go along. And if you have any, if there are any problems with the presentation, then please let me know as soon as you can. So a quick recap of what Clean Code is. Does anyone want to start us off with their idea of what Clean Code is?
Okay, I'll have a try. Making it easy for people to read your code by just developing some kind of clear, neat standards that are easy to process.
Yep, that's a good start, Marie. I think the definition that I gave last time is that it's easy to understand, but also importantly, it's easy to change. Because code that's easy to understand is one thing, but if it's then difficult to actually make changes to that code, then your code is not going to stay clean for long. How do you know whether you've got code? And it's really about when you're looking at the code for the first time, how many questions per minute does the code generate? If it's clear what the code's doing, there won't be too many questions, so you'll end up with good, clean code. So thanks for that, Marie. If anyone has not seen any of the introductory video or the video that we had on naming the first Clean Code Nugget, then those are available. And if you don't know where they are, then please let me know via Yammer and I'll provide you some links. So when we're looking at functions, there are a couple of concepts that are important to understand. The first one being, what is a function? It seems a very simple question. So hopefully someone on the call will have an answer to this. What do people understand by what a function is? Any suggestions?
A bit of code that sort of maybe takes something and maybe returns something.
Yep, that's a good start.
I would say it definitely returns something.
Well, it doesn't have to return something. You can have functions that actually perform an action but don't return anything. They return a void. That's not necessarily returning something.
Is it just a small entity that does something and that is easily repeatable because we can call it from one line?
Yeah, I think that's a good way of thinking about it. The way I normally think about it is it's a set of instructions that perform a specific task. But the other way of thinking about it is that you're taking a task and you're decomposing it into instructions at a lower level of abstraction. And that obviously begs the question, what is a level of abstraction? And that's the second of the concepts that we need to deal with. So the idea of abstraction is that you're trying to summarize something to hide some details that aren't necessarily relevant at the level that you're looking at it. And the other way of thinking about it is that you start at the high level of abstraction and you go down to a lower level. It's a similar concept to the idea of higher level code and lower level code. What I mean by that is let's take a simple example where you're maybe trying to get the yield from a wind farm. So at the really high level, at the top level, you have a function that's calculating the energy yield for the whole wind farm. Obviously, that doesn't give the details of exactly what you're doing to do that. But as part of that function, you then might calculate the contribution to that yield at a particular wind turbine location. So you're getting into a little bit more detail there. And to do that, you'd probably have to calculate the wind speed at that particular location. To do that, you'd probably have to do some kind of interpolation to work out what the wind speed is at that particular point. And to do that, you'd probably have to carry out some basic mathematical operations. And those will involve they'll be broken down into binary operations that are sent to the CPU. So at this lowest level, you're not hiding any detail. It's all about detail. But as you move further up to the higher levels of abstraction, you're potentially hiding some of the details of what's happening to the lower level, but you're giving a summary of what's going on. So you're trying to give an idea, an appropriate idea of what that function is doing for the level that you're looking at it. Does that make sense to people?
Yes. Yeah.
Yes.
Yeah.
Okay. So we'll come back on to levels of abstraction a bit later on, because that is one of the guidelines. A little bit of foreshadowing there for you. So those were the two concepts. So roughly a function is a set of instructions, and you're trying to break it down into different levels of abstraction. So if we then go on to look at some of the guidelines for writing good functions. And the first guideline is, well, I'm not going to tell you that just yet. I'm going to let you guys guess what this first guideline is by showing you an example of a function. And if you guys can guess what guideline we're trying to show through this example. So here is the start of a function called execute. And this function goes on, and it continues, and then goes on a little bit further, and it goes on further, and further, and it finally finishes. So the question is, what is this first guideline? What is wrong with this function? Does anyone want to give me a guess as to what the problem is with this function?
I think the font size is too big. You can't see it all on the screen at the same time.
Yeah, I think font size might be hiding the problem, the more general problem.
It's too long. Also, all the comments are in different languages.
Well, yeah,
the comment shouldn't be there really if your attributes and stuff like that are named properly.
Oh, that's a very good comment. Oh, thank you for that. Yes, that's a good point about comments. Comments. If you're writing good, clean code, you don't probably need comments. The other question about language is a very interesting one. Yes, some of these comments are in French. There might even be a little bit of German hidden in there somewhere that might have snuck past everyone. But I think someone did come up with the important question that it's too long. And it's the general point with functions. If you start getting, the shorter a function is, the easier it is to understand if you've written it well. Obviously here we're talking about 7-8 screens worth of function. I'd say that was too long to understand. The basic reason being it would take you a long time to actually work out what that function does. You'd have to read through all of those different screens. You'd have to scroll up and down. and it would take you a long time to do that. How do we get around this problem? Well, we can start to refactor. You can take the different parts of the function, refactor them into subfunctions, and we can take this to an extreme. We can actually boil this multi-screen function down to 3 lines of code, where we're setting the input parameters, we're then creating Solar layout shapefiles, and then we're writing the output CSV file from that. Now you could well argue that we've gone a little bit too far in this refactoring, that it's difficult to understand because we've gone too far. But as long as the subfunctions that we've got are written well and refactored well, then we should actually be able to understand this in an easier way by doing this refactoring.
Steve, can I ask a quick question about the name of the function?
Oh yes, yep. I'm glad you raised that. That was the other point in here.
Before you went on and on and on with all the different screenshots, I was kind of thinking that is not a very clear name. Execute what? But I don't know. In terms of that line, what you would do?
You've spotted the other little thing that I hid in there, Maureen. Yes, this function has got a terrible name. It should be called something along the lines of create Solar layouts. I can't remember exactly what it's doing, but yes, you're right. The name of this function is bad as well. It's almost as though you looked at the naming Clean Code Nugget recently, Maureen. But yeah,
almost just like that.
Yeah. Thanks for bringing that up. That's another point. But there's also the point that if you can write shorter functions, they're going to be easier for you to understand. Any other questions or comments on that guideline? I'll take that as a no then. Okay.
Just one question, really, Stephen.
Yep.
Is there, when you have a potential for a lot of functions where you actually end up having to trace down between multiple levels of function, is there considered an optimum size for functions, as opposed to you could have 100 different functions with one line of code in each, as opposed to one function with 100 lines of code, both of which are difficult to read? Is there something considered the optimum?
I haven't come across any definition of what the optimum is, and I think it also depends on the team of people who are actually going to be reading the software. I take your point that you can take things to an extreme, and to be honest, I think I may have taken it too far here by breaking it down into too short a number of functions here. Although I think Sed may have a comment on this.
I'll just put in a link to a sort of blog post about it. Which is sort of be interesting, sort of associated reading.
Yep.
It sort of depends on the thing, I think, really. Like, it's sort of like nesting is sort of, I think, like another bad thing. So ideally, you want things to be sort of at the same level if you can. And the deeper the nesting is, the more confusing it is. And say if you had a long function where every call was basically the same, like maybe that would be better than just sort of like splitting up into lots of different ones. But yeah, it's sort of context sensitive. But generally, it is true. But the shorter it is, the better it is. And there's no real bottom limit on that. Like one-line functions are, usually the best ones.
What I will do is at the end of this call, when I put details up on Yammer, I will put that link up there and any other ones that we come across during this presentation.
Cool.
But, yeah. Does that answer your question, Ian?
Yep.
Okay. So the second guideline is that your function should do one thing. The quotation that's normally given is functions should do one thing, should do it well, and they should do it only. And the obvious follow-up question is, what do we mean by one thing? Do we mean one line of code? Do we mean one operation? Probably not. The best way that I've found to think about it is that one thing is really one responsibility, and the other way of looking at that is one reason to change. So what might cause your function to change? So if we look at a quick example of this, I'll just put together a simply named function to create and print a report. Now, why might this function change? Well, it could change because we actually want to put more content into the report. For example, you might have new results from a calculation that you want to include in that report. But similarly, you might find that you want to change the format of that report. For example, when you print it, you might want to send it to a printer, you might want to print HTML, or you might want to print a PDF instead. So there are those two reasons why it could change. And so you've really, in this function, you've got two responsibilities. And so it's really doing two things. And there's another little clue to the fact that it's got two things, and that's that you've got and in the middle of the name of the function. So this it takes a little bit of time to work this through and get familiar with this concept. But if you do have something that you think has more than one responsibility, the way of getting around that problem is to refactor it into two separate functions. What we've done here is we've got create report, and that can change because we want the content of the report to change, and then we've got print report, a separate function that may change if we want the format to change. Does that make sense?
Yes.
Yep. Yes.
Yep.
Okay. So the third one, the third guideline is to try and keep a consistent level of abstraction. So when we were talking about abstraction, it's kind of what level of summarizing you're doing, what level of detail you're hiding or showing. And it's best to look at this through another example. Here we have part of a function. And you'll see in here we are setting up a member variable. We're making a call to that to write some details. We're setting up another member variable. We're making a call to a subfunction. Again, writing a message, calling another couple of subfunctions, writing another message, doing a quick check, writing a log message, calling another subfunction. So the calls where we're actually changing the member variables, again, that's quite a low level of abstraction. We're not really hiding any detail there, whereas the calls to the subfunctions are at a higher level. We're hiding the details of what we're actually doing within a subfunction. How do we make this get a more consistent level of abstraction in this function? Well, again, it's to do with refactoring. So we can do a first pass through the refactoring, and we've moved the creation of the member variable, the log obj, down into a separate setup log writer function. Similarly, we've moved one of the writing messages to the log and the creation of that member variable. We've moved those down into a separate setup drawing reference subfunction, and then we've got other calls to get some details, check them, get some other details and check those, and then get the data frame coordinate system at the end. And we could take this a step further as well, because we've kind of got three different sets of functionality here. The first two functions to do the setup, the next four are to do with checking, and the final one is just getting the data frame coordinate system. So we could again break it down. So we've got a top level setup function that calls those two setup subfunctions, and we've got a check drawing properties function that again calls the lower level functions. So we start off up at the top level. Now we've got a consistent high level of abstraction, and then in the subfunctions we've got a lower level of abstraction. So hopefully if we're coming to read this function for the first time, we can see that we do some setup, we check some drawing properties, and then we get the data frame coordinate system. Hopefully that's a lot easier to understand than the original. Any questions or comments on that? so moving on to the fourth of the guidelines, we want to try and separate commands and queries. What do I mean by commands? Well, command query separation is the normal terminology that's used in software. I personally find command can be used to mean a lot of different things. So sometimes we refer to those as modifiers or mutators. And functions that are commands, modifiers, or mutators are actually changing the state of the system. They're carrying out some change, but they don't normally return a result. So they're potentially updating a calculation, for example, but they wouldn't return the result of that calculation. And that's the flip side of that is a query, where you are returning a value, but you're not changing the observable state of the system. And a function should really either be a command, modifier, mutator, or a query, but not both. So a simple example would be your standard get-set methods. Your set is a command or modifier where you're passing a value to it and you're setting an internal variable, so you're changing the state. Whereas your get is just a query, you're not changing the state. So why is this important? Well, queries are a lot safer to use because they don't have any side effects. They're not changing the state of the system. So you can call, if you've just got a query that's not changing the state, you can call it multiple times in any order, and you won't change the state of the system. You end up with the same system. Whereas commands do change the state of the system, so you need to think about them in a little bit more detail. The order that you call commands will potentially change what you get out at the end of them. The number of times you call them will again make changes. So they're a little bit less safe to use. And so one of the main reasons for having commands not returning a result and queries returning a result is it's easier to differentiate what is a command, what is a query. And if you can be consistent about that, you can know that if you're returning a value, it's a query. You don't need to think about it in too much detail. Whereas commands, you're going to need to think about it because it is going to change the state of the system. Okay. Any questions on that?
Not for me.
Nope.
Okay. The fifth of the guidelines is no side effects. And what we really mean here is no hidden side effects. So if you're trying to carry out an operation, you don't want it to have a side effect of changing a part of the state of the system that you wouldn't expect it to. It's a bit difficult to find examples of that in our code because we've done a pretty good job so far. But here's a standard example of a function that's checking whether a password is valid. And can anyone spot the hidden side effect in this function?
No one else is going to say it. Session.initialize.
Ah, you found it in. Yes. So you might just think that you're checking whether a password is valid, but halfway through this, if it is valid, it's going to initialize a session. You may already be in a session, and then your session will be changed. It's not clear that that is what is actually happening here. So how do we get around this problem if we spot it? Well, the first thing we could do is change the name of the function to represent the functionality that we have there. But you'll end up with some horribly named function. Check password validity and initialize session if valid. It's not. There's a bit of a code smell there. It doesn't sound like it's a sensible thing to do. Now the alternative is to actually look at the usage of this function and determine whether you do actually need to initialize a session if you have a valid password. But that's going to take a little bit more time to do. It's going to be more difficult to do. You're going to have to review all of the usage of that. And it's going to take a lot of time and effort to fix that up. But it's something that is definitely you should do if you do find those side effects. And those side effects can lead to very difficult to find bugs in your code. So it's worth making sure if you do spot those side effects, you do try and fix them. So moving on to the next of the guidelines. You want to try, if you have a function that is taking in arguments, you want to try and minimize the number of arguments that come in. We have some functions that have literally dozens of arguments coming in. That's not a good thing. As to how many is a good idea, some people would suggest 7. Some people would just suggest 3. But the general the rule is, the smaller your list, the easier it is to understand. There will obviously be limits to that, but generally, the smaller the list, the easier it is. Let's look at another example. This is a function call, or a function that has 8 different badly named arguments. How would we reduce that? Well, we can see here that we've got 3 of these values: temp inner, roughness inner value, and height inner are all referring to inner, whereas temp outer, roughness outer, and height outer are all referring to outer. So we can group these arguments. We can create a separate class that contain those details. So when you're creating the class, you pass in a feature class, a roughness value, and a height value, and then you could pass instances of this class into the function. So you'd then be able to minimize or reduce the number of arguments coming in. So you're passing an inner roughness that would give access to what we previously termed temp inner, roughness inner, and height inner. And similarly, outer roughness would give access to the temp outer, roughness outer, and height outer. So you've gone from 8 to 4. You've halved the number of arguments that you've got there. And hopefully you'll agree that that would probably be easier to understand when you're making a call to the class. And also within the class, it would probably be easier to understand that you've got 3 values that are referring to specific roughness details.
Steve, quick question on that, if you don't mind.
Mm-hmm.
Would you really create a class for something so small instead of maybe just having a definition that would create a list or something like that?
I mean, in C#, I wouldn't go to the detail of actually creating a class. I would create a struct, which is kind of similar. The problem is with creating lists, then is a list a similar thing to a class? It's a good question.
I think sorry, carry on, Steve.
No, you go ahead, Sid.
Again, I think it's a bit like sort of making functions small for me. I think there's no sort of lower limit on how small a class should be. If it does something useful, sort of like it does here, I think that's fine. From my point of view, at least.
I think it also depends on your usage. So, if it's going to be used as a single dictionary that you're going to store in as the attribute or as an attribute of another object, you might not want to do it this way. But if you're going to have something that's like needs to be typed very specifically, and you're going to be iterating over loads of them, then maybe you want it in a class object because it just makes your life easier and it's more strongly typed. Does that make sense?
Yeah, thanks.
Yeah.
I think, like,
What
if you have a
much-
class, do you'll get sort of IntelliSense and IDE as well, which is quite useful.
Yeah, I mean, one modification I might make here, Steve, is that I would actually give a type hint, and you can do that for where the classes are going to be used.
Right.
Because inner roughness,
Yes.
that's a little bit ambiguous, that it's expecting to receive a class.
Yep, that's true. We've actually gone through a couple of iterations of what we call these input arguments. But yeah, you're right. If you can give a hint as to what it's actually expecting, that would give more information.
It's worth mentioning the new data classes in Python. They basically reduce the ceremony of creating classes. So it's basically, I don't know, like 4 lines of code. If you wanted to just create a small class with just fields on it, properties. I'm just pasting a link now.
Okay.
They're definitely interesting. I find them very confusing, Paulus, but it's probably my own lack of knowledge. They don't always act the same way that you're used to classes acting.
Yeah, I haven't used them, but they look like they've been created for this kind of thing. But
yeah,
you never know.
Mm-hmm. Okay, thanks,
Yeah.
Paulus.
Yep. So I was trying to say it probably depends a bit on what features you have in the language you're using. Like you said, you'd probably use a struct for this in C#, and in Python you'd use a data class or a tuple or whatever is available, or just a class as you have done here, an ordinary class. So there's no single answer. It depends a lot on what features you actually can use.
Yeah, that's true. And I think the one limitation we have here is that I haven't given the full content of the function to see how it's used, how those variables are used internally. I didn't want to put too much detail into this.
Okay, no, well, thanks very much. It's good to have all your ideas and feelings on how to deal with that.
Also, just as well, if you're kind of taking a class and putting it, say, for some people who might be less experienced with programming, if you're taking this class and putting it off on its own, so someone can look at it on its own, then that can just be helpful for someone as well who's kind of reading it, this kind of thing. So although it does seem like a faff to make that class, if it can improve the readability for someone who might be a wee bit less experienced, then it can be really helpful as well.
Yeah, and when I was saying type hints earlier, sorry, I was being Python centric. There is the concept of type hints in Python 3. I'm just going to paste the link. It's PEP 484 standard, which was part of PEP 8.
Okay. Right. Thanks very much for that, guys. As I say, I'll put those links into a Yammer post at the end so everyone has access to it. Okay, shall we move on to the final guideline?
Yeah, let's do it.
The final one is don't repeat yourself. Repeated code, duplicate code, it's not only a waste of time, it takes more time to understand, but it can lead to some real world problems. Again, let's have a quick look at an example. It's the same example we used earlier. Can anyone spot the repeated code in here?
Is it the self.logObject.writeMessage calls?
That's the example that I was dragging out from here. Thanks, Chris. So we've got 3 separate calls to the log_obj write message. You could argue that we're not repeating code here because it's making a call to a function within the log writer. But what would happen in the future if when we were logging a message, we wanted to do something a bit different? Maybe we wanted to log it to 2 separate locations. We might want to do all kinds of different things. We might want to include a timestamp on the log message at the start. If we were to make those changes, we'd have to make those changes in 3 separate places, potentially. a simpler way is to refactor that duplicated code out into a separate function, log message. In the initial refactoring, that would just make a call to the log obj write message, but we might find that we wanted to include, for example, if we wanted a timestamp, you could easily change that in one place in log message to concatenate on timestamp onto the start of this. So we've removed the duplicated code just simply by refactoring it down into a separate function. Obviously, not all of your refactorings to remove duplicate codes are as simple as this, but it's the general concept that you don't want the same code to be repeated.
Steve, like I would argue that if you wanted to make a change like this, you probably use a different log writer.
That's true.
But just this seems to just add more, I guess, noise to it. To be honest, but maybe that's just me.
I don't know. You might log it to 2 different places, for example. I mean, the thing is, you have to create a log writer as well as call it. So I guess you might actually pass in some other thing, mightn't you? Like you might pass in a logger, which has already had the thing in it.
Oh.
I mean, I guess if you want to use a different sort of logging thing, in the second example, there's less to change, right?
Mm-hmm.
Yeah, I take your point, Paulus, and this is I was looking for another example on this because it does have potentially that drawback. That there are a number of ways to do this, but in general, we do want to try and. Would you agree that we don't want to duplicate code if we can avoid it?
Yeah, of course.
And I'm not saying that we've completed the refactoring in this function. This init function is still in need of some significant refactoring, as we saw earlier. But it does go to show that sometimes the refactorings that you're doing, other people might then look at it afterwards and think, hang on a minute, I don't really understand what's going on here. What we are trying to do is to make code easier to understand, so potentially this is a good thing, but other people may not understand it in the same way that you do.
Would you not say the point in time to do this refactor is when one of the instances crops up where you want to make a change to log message, at which point it would be clear whether you wanted to create another class to do the logging or whether just having a function within this this same file is appropriate?
Yeah.
I mean, you're refactoring at this point, but whereas the worst case you're trying to avoid is having to do the same amount of code possibly at some point in the future.
I do agree with you there, Ian, that would be the time to do that refactoring. But I think the other point is that if you're looking at code and you're not understanding it, or you're finding it difficult to understand, then potentially, if you've had to go through the overhead of trying to understand it, then at any time, if to understand it, refactoring helps you to understand it, then it's best to actually do that refactoring there and then, so that when other people...
That definitely applies when you've got multiple lines of repeated code, because often it takes a little while to actually work out they're exactly the same.
Yeah.
And once you've worked out they're the same, that's a good point in time to say, actually, this is the same code. Let's make it 2 calls to the same method or whatever.
Yeah. So you're right to raise the point of when to do refactorings, but I think that's if you're finding something difficult to understand, that's a code smell that it does actually need to be refactored. Okay, is that clear to everyone?
Yep.
Okay. So that's the 7 guidelines that I was going to just go through. There are obviously more things that you can do to get better functions, but I think this is those 7 are probably a good set to be going on with. So we've covered couple of simple concepts of what a function is. We've dealt with we've introduced the levels of abstraction, and then the guidelines that we've looked at are shorter is better, do one thing, try and keep a consistent level of abstraction, try and separate out your commands and queries, try and avoid side effects, minimize your arguments coming into a function, and don't repeat yourself. So that is the end of this presentation. Does anyone have any general questions that they wanted to raise at this point? And if not, thanks very much for attending, guys. As I say, we will be having another nugget in the near future when we'll be looking at classes and how to write cleaner classes. But thanks very much for attending, and happy coding.
Thanks, Steve.
Bye.
Thanks, Dave.
Thanks, Steve.
Steve.
Bye.
Thanks, guys.
Thanks, Steve. Bye.
Bye.